Okay, hello class. Let's look at this kind of question. So here we have two drawings, and I would ask you to find the scale factor of this diagram. In this case, we have A and A prime. So A prime is always the scale because it has that prime. The original one, no prime, and the prime here is this sign here. We say this is prime. So this is how you, if you're just looking at the drawings, you know which one is the scale, which one is the original. Okay, so scale factor. So this is what we're looking for here, the scale factor. So what we're going to be looking here, these drawings are given to you on a grid. So you have one of two kinds of questions. I would either give you the lengths or I would give you the drawings on a grid. And also make sure that you have the width and the length, and you need to compare those together. So the original is standing on its width, where the scale, it is rotated on its side, so it is actually sitting on its length. So be very careful about that. That's very important here, because you don't want to be comparing the width to the length, which would be 1 pretty much. So be very careful to choose the proper side. So you're always comparing the width with the width. If you're standing, for example, if it's a picture of a person, you're gonna go from the feet to the head and not from shoulder to shoulder. So be very careful about the orientation of the shape. So here we're looking for the scale factor. So let's look at what we have. Let's call it SF just for short. So the length on the scale we have, we can pick the length or the width. I'm going to pick the length because that's the one I'm looking at right now. So the length, 1 over length, and that would be, we have the length is 4 squares, and the length of the original is 1, 2, 3, 4, 5, 6, 7, 8. So we have 8. Okay, so that gives us 1 over 2 or 0.5. It doesn't really matter, I don't care. So 0.5 or 1.2 or 1/2, we know the scale factor is going to be 0.5, which means it is a reduction. Not surprising. This is the original is A. If you look at it, it's a much larger, it's twice as large actually as the smaller one there, and that's what the math shows here. Okay.